Yes, good morning, children. Continuing, we are doing the revision today of gravitation chapter. Gravity, as you all know, is one of the basic force in the universe. It plays fundamental role not only in the structure of our solar system, but also in the way objects behave on the earth. What is gravitation? It is the force of attraction between two objects in the universe. Gravitation may be the attraction of the objects by the earth, children. This force is proportional to the product of the masses of the object, and it is inversely proportional to the square of distance between them. And it is independent of any medium. Gravitational force is represented by F, whose formula is capital G into M into small m upon r square, where capital G is, children, the gravitational constant, capital M is the mass of the earth, small m is the mass of the object, and r is the radius of the earth, or we can say the distance between the two objects. Okay. For example, if a body is dropped from certain height, it falls downwards on the earth due to earth's gravity. And if the body is thrown upwards, it reaches at a height from where then again it falls downwards due to earth's gravity, children. So gravitation may be the attraction between the objects in the outer space, that is the attraction between the moon and the earth, or the sun and the planets. A natural satellite, a natural force is the gravity, which pulls all the objects towards the center of the earth. It holds the stars together. It also binds the galaxies together for billions of years and prevent planets from losing their atmosphere. Children, universal law of gravitation states that every object in the universe attracts every other object with a force which is directly proportional to the product of their masses, and it is inversely proportional to the square of their distance. As you can see in the figure, children, this is a mass of this is earth, and this is an object. This is capital M is the mass of the earth, and small m is the mass of the object. And F is the force of attraction between the two, which are exerting both of them on each other. Okay, and D is the distance between the two objects having the masses M. Then we say that the gravitational force of attraction is equals to capital G into M upon D square. The SI unit of G is Newton meter square upon kilogram square, and its value is 6.673 into 10 raised to power minus 11 Newton meter square upon kilogram square. Yes, children, the strength of this force depends upon the distance between the two objects. How big are the objects and how far apart they are from each other. Now we are going to start the concept of the free fall, children. What is free fall? Can you tell me? What is a free fall? When with the negligence air resistance, falling objects can be considered freely falling. Objects of different shapes accelerate differently, stone versus feather, for example. So what is free fall? Today we are going to read about free fall, children. Free fall means anything falling on its own only under the influence of gravitational force, and no other force is acting on the object. In that case, what happens if you drop two objects from the same height, let it be a stone or a feather, and during free fall, what will happen? Both will fall at the same time when no other force is acting on it. This is free fall. To calculate the value of acceleration due to gravity with which the objects are attracted towards the earth, the acceleration due to gravity is denoted by small g. The unit of g is meter per second square, children. And from the Second law of motion, you know that the force is the product of mass and acceleration. But for the free fall, force is the product of mass and acceleration due to gravity, which is denoted by G. You can see here that F is equal to M into G. And you already know that the force of gravitation is equals to capital G into M upon R square. So we can say that if we cut small m into small m, that is mass of the object from both sides, the gravity becomes what? Capital G into M upon R square, where m is the mass of the earth and d is the distance between the object and the earth. Now children, then comes the mass and weight. Mass is a fundamental property, universally property, which is same everywhere, no matter where you are in the universe. But weight is not a fundamental. Its value depends upon the circumstances in the universe, because weight is a force and it is a resultant gravitational force exerted on a body with mass m by all other bodies at the universe. So weight is equals to, we can represent it as a force which is equals to G into M upon R square. That is where ME is the mass of the earth and R is the radius of the earth. Yes, children. Okay.